Adding vectors. This can be broken down into 3 easy steps. You take each vector and you convert it from polar into Cartesian coordinates or rectangular coordinates. And then you will add those rectangular coordinates together, and then you will convert back from Cartesian coordinates into polar coordinates. And that is it. That's all you got to do. Of course, you want to make a graph and measure. You can measure, or you can just kind of draw rough, like just eyeball it for a good reference point. But overall, you just need those three easy steps. So here I have these. I'm going to add 3 vectors together, and they're all in polar form right now. So very first step, just go ahead and convert each one into Cartesian coordinates. So you have 3, the first vector here, and we can draw what it'll kind of look like. I'm not going to measure. I'm just going to kind of eyeball it for a good reference. So it's 3 meters per second is the magnitude, and it's a 45-degree angle. So it's going to kind of cut right through this first quadrant right there. And we can kind of do the math along with it. 3 times cosine of 45 degrees. And then we'll do 3 times sine of 45 degrees. And we'll just do the math. And let's kind of get the concept here first before we do the arithmetic. That way we can just kind of get it all out of the way. So this second vector is going to be a magnitude of 5, and it's in 135 degrees. So that's over 90 degrees. It's going to be, and we're still basing it off of the x-axis, the positive x-axis right here. So 135 degrees based off of this x-axis. It's gonna, and it has a magnitude of 5, which is greater than the first one. It's gonna cross over into the second quadrant, something like that. And the math behind that is gonna be 5 times cosine times cosine of 135 degrees, and 5.0 times sine of 135 degrees. And then the third one is it's going to have a magnitude of 2, and it's going to be 60 degrees. So kind of going right back at that towards the first quadrant. And it kind of looks close, like it might be in the first or second. I'm going to cut it short right there because we don't know yet, but we can, once we look at the resultant vector, if the resultant x coordinate is negative, then that's a dead giveaway that it's going to be on the left side of the graph. And so we'll just keep it right there, and we'll go ahead and start doing the arithmetic so we can kind of gear it down and see where we're actually at. So we will have 2 times 60 and 2 times cosine of 60, and then 2 times sine of 60. And a good point here is to know that they're in degrees, so the direction will be in degrees. So we're going to want the calculator that we use to also be in degrees. So this little calculator, we're just going to take 3 times cosine of 45 degrees. And since it's 45 degrees, we know that it's going to be the same. The x and the y will be the same, so it's 2.12. So both x and y coordinates will be 2.12. And if you look at it right here, you can kind of see it's cutting it in the middle, so it's going to have the same values on the x and y axis. The next vector is going to be 5 times cosine of 135 degrees, which is negative 3.54. We'll just round up, negative 3.54. and the y coordinate will be 5 times sine of 135 degrees, and that's positive 3.54. Okay, now we're going to do that same thing for the third vector. 2 times cosine of 60 degrees equals 1. Keep getting my colors wrong. Equals 1. And 2 times sine of 60 degrees is 1.73. So now we have our Cartesian coordinates. We have the Cartesian coordinates, and we're just going to add them together. And you just simply add all the x's together and then separately add all the y's together, and you've gotten your resultant x and your resultant y. So we'll take 2.12, which was this one right here, the first one, the x. We're going to add all the x's first. So 2.12 plus negative 3.54, the ugly 5, 3.54 plus 1. And the y's will, so the first vector had the same y coordinate. So 2 plus positive 3.54, because this y was, this x was negative, but this y right here is positive. So plus 3.54 plus this last y right here, 1.73. And so the results of these will give us our new x and y coordinates. So just crunching that through the math. So the x coordinate equals negative 0.42, and the y is just adding all the y coordinates together. 7.39. So we have our x and our y coordinate. Let me go ahead and change this color. All right. So we have our x and our y coordinate. And now one thing we want to take note of is the x coordinate right here. This is negative. So and the y is positive. And so this means it's going to be in the second quadrant. Now this is important because now we know it was actually in the second quadrant and not in the first. So we can go ahead and just draw it like that for our visualization purposes. And an important part here is that tangent, the range of tangent is only in the first and fourth quadrant. And they stop right before 90 degrees because your adjacent, your x, is going to be approaching 0 at both of those. Once it hits 90 or 270 degrees, it's going to be 0, and you can't divide by 0. And so this tangent right here, it works out so that it only covers the first two quadrants. And so we know that the answer that we get for the theta, because theta right here is going to be arithmetic using tangent, we know that we're going to be limited to those first two quadrants. So we're going to need to do some kind of math. We'll either have to add by 90 if the answer, so we'll have to do plus 90 if the answer is in the first quadrant, and we'll have to do plus 180 if it's in the fourth quadrant, because we know we're going to have to get it to that second quadrant. So we're gonna go ahead and get the magnitude. The magnitude doesn't really matter too much. It's just we have r equals the square root of 0.42 squared. You say negative, it'll give us the same answer, plus 7.39 squared. Now this is going to equal, we'll go ahead and just put it in the calculator real quick. The square root of 0.42, let me use my parentheses, of 0.42 squared plus 7.39 squared, and it's the square root of all of that, and that gives us 7.40. So the magnitude is 7.40. So the length of it, and we're in this problem, for all these vectors we have meters per second. We didn't have to change anything since they were all the same. So 7.40 meters per second. Now finding the direction, this is where we have to take into account. If the answer is in the fourth quadrant, we have to add 180 degrees to it to get it to the second. And if it's in the first quadrant, we have to add 90 degrees to it to get it in the second. So, and it's kind of, if we made this graph the unit circle, we would know this is 0 or 360 degrees. This is 90 degrees. This is 180 degrees. And this is 270 degrees. And so you can tell that every quadrant represents 90 degrees. So you're just moving it over one quadrant. And the way to represent that is if you just want to move it over one quadrant, add 90 degrees to 180 degrees. So, and it'll depend on the answer we get here. So we're going to say arctan of opposite over adjacent. So arctan of 7.39 over negative 0.42. Go ahead and punch that in the calculator and we'll see what we get. So arctan of 7, and you can just push the inverse button and it'll change your trigonometry, at least for this Microsoft Bing calculator. It'll change your trigonometry equations to the arc versions of them. So we have 7.39 over negative 0.42. That gives us negative 86.75. So negative 86.75. Now when you're talking about the unit circle, you can go downwards and you can either calculate, you can go downwards and call it negative, which that's what it just did. So tangent just went downward from the positive x-axis and it's given us a negative number. The other thing that it could do is it could wrap all the way around, meet that same point, and give you a positive number, and just out of the 360 degrees. It doesn't do that. It just gives you the negative number from the positive x-axis. So we know we're in the fourth quadrant. So we know we need to move it 2 quadrants over, going counterclockwise. So we're going to have to add 180 to move to second quadrant. So that new number, so plus 180, gives us 93.2. Let's see what that last number, 0.25. So we'll round up. We'll say 93.3 degrees. So the resultant in polar form right here is going, the answer is 7.40 meters per second at 93.3 degrees. And that's it. And that was a 3 vector. The same for the 2 vectors. It doesn't matter If your triangles crisscross like it does here, the same concept always applies. You just want to keep an eye on what quadrant you're in. You don't have to do any measurements to know what quadrant you're in. Just as long as you did your calculations correctly and you look at the resultant vector's new x and y coordinates before you take it back to polar. If you look at the rectangular coordinates or the Cartesian coordinates, you look at the sign of the x coordinate and the sign of the y coordinate, and that will always tell you what quadrant you're in. You can either have uh, an x positive, y positive for the first, x negative, y positive for the second, negative, negative for the third, and positive, negative for the fourth. So no matter what these signs turn out to be, that tells you what quadrant you're going to be in. And you can use that at the end down here, using that knowledge that you got right here. Take that with you when you get the direction of tangent or the direction of theta. Hopefully this video was helpful, and go ahead and leave some comments. Let me know if there's anything I can improve on, or uh, if it was just all good. Go ahead and subscribe, please, if you like the content. And yeah, thank you for watching. Thanks.